Hello and welcome to SudoKanard. Here is a puzzle that was made specially for me by Australian author ChocChip, and here it is. So it has this very special title x plus v minus plus q equals SudoKanard et plongée by Pépite de Chocolat, which is the literal translation of ChocChip to French. Right, so that's a very nice tribute and sequel to the previous puzzle by ChocChip that I sold on the channel. And I suggested that he do a quadruple Sudoku puzzle with xv, but with the negative rule of xv, and this is what this minus sign here means. So the rules are that whenever you have this, it means that the 4 digits must appear in those 4 cells. So that's basically pencil marking. Whenever you have a symbol X, it's actually the Roman numeral 10, which means that the 2 digits must have a sum of 10. With V, it's the same with Roman numeral 5. And the negative rule specifies that whenever you don't have a symbol between 2 cells, it means that the sum won't be 5 or 10. And that's it. So the negative rule should be able to allow us to fill all those empty cells. And so where do we start? This is a fun place to look because we know there must be a 1 somewhere, and we know that 9 won't be next to the 1, so if 1 is here, then 9 has to be here, and the same happens with 2 and 8 because two neighboring cells can't have digits summing to 10 in those places. Well, perhaps the first thing to note is that those 4 digits and those 4 digits must all be from 1, 2, 3, 4. So one of those pairs will be 1 plus 4, the other will be 2 plus 3, and the same happens here. And each one of them is paired with a digit from 6 to 9, except for this one, except maybe for this one. I can't say with certainty at this point. And we see that on this row 9 is in one of those 4 cells, so 9 won't be in any of these. So those digits are from 2, 4, and 5. And we see that 1 and 3 must be somewhere in here. And 9 must be somewhere in here. Something else I'm seeing is that here I get an 8 and a 9, and the same happens here. So 8 and 9 don't appear in those cells, so they must both be present in some place here. Something else is that there is a 1 and a 2 here, so 1 and 2 can't appear there, and to satisfy this clue I must put 1 and 2 here, 5 and 6 here. I won't pencil mark 1, 2, 8, 9, it's already done. And the remaining cells in the block must be 3, 4, and 7. We know that 3 and 7 are not next to each other because we would need the symbol X between them. So one of those is in here, and you see that there's a 4 in here. So that 4 does not appear in those cells. So that this is 2, 5, or 9, and 4 is in one of those 2 cells, oops, which means that this is actually a 2, 3 pair, and down there we get a 7, 8 pair, and up there that's a 1, 4 pair, and that's a 6, 9 pair. All right. And because there's a 2 here, the 2 must be here, so we don't have a 2 in here. That's 4, 5, or 9. 1 is not here because of the 1 here, so we get a 1 in here. And 6 must be somewhere, not sure where, not sure This can be determined at this point. All right, where do we look next? I don't have a lot of possibilities, I think. There's a 4 in here. So 4 could be there. Or it could be one of those. If I put 2 and 3 here, then 2 and 3 will appear somewhere there. 3 in here, 2 there. 2 there, so 3 will be here. Because I don't have a V symbol between those two. On this row, I already have located 5, 6, 8, and 9. And 3 can't be here. So the options are 1, 2, 4, and 7. I usually don't pencil mark 4 possibilities, but sometimes you have to do what you got to do, what you've got to do. So 5 is not here, 5 is not here, so there's a 5 in here. And with the XV constraint, 5 is the less restricted digit there is, except that it won't appear in such a place, but with the negative rule 5, you can't do much with 5. Let's just notice that 9 is in one of those two cells. So we won't have a 9 in here. And actually there's another reason why we won't have 9 in here, is that we would have 1 and 9 next to each other without an X symbol. And we don't have a V symbol, so those digits can't include a 4 for the same reason. So 4 and 9 are both in here. And so that's not a 4. And 9 is not here, so there's a 9 there, which means that this is not 9, so this is not 1, that's not 4, and that's not 6. And those are from 3, 6, and 8. So 4 and 9 are both in here. And 4 is not, because of this, 4 is not here, but we already knew that. But 9 could still be here. Is there any other restriction? 9 here would prevent this from being a 1, but that's not saying much. Is there anything more about this? I'm missing something there. Actually, this cell is quite restricted. It can only be 5, 7, or 8. This also is restricted to 2, 3, and 5. And on this row, there must be a 1 somewhere here. And that's interesting because there's no V symbol between those cells, so we can't have a 4 and a 1. So on this second row, 4 can only be here. So that's not 4. And we now know that 6 can't be here because we would need an X symbol. So here we have a 1, 6 pair. And this is 5 or 9. So 5 and 9 are not here. We get a 5 in here. And 9 could be here, but it could also be here. So here we are with 1, 2, 3, and 5. Here there must be an 8. No, oh, that's not true, but there must be a 6. Which there again is not very interesting, I'm afraid. Oh, but there's a 1 in here. And there's a 1 in there, so we don't have any 1 in here, so we must have a 1 somewhere there, so 1 must be here, and that's a 2. So there's no 2 here, so 2 must be there. We know that 2 and 8 must be on opposite cells on the diagonal, so 8 must be somewhere in here. So 8 is here. Is there any restriction on 8? So 8 can't be anywhere in here. Not sure what to do with that. There must be something with the negative rule. Well, everything revolves around the negative rule anyway. But it's a bit like with anti-night Sudoku. There's always a possibility that you've missed something, that I've missed something. 9 here would put a 6 there. All right. 9 here would achieve absolutely nothing. So 1 and 2 here. Not seeing what must be done. Is it about the remaining digit here? 3, 6, 8, and 9 don't have strong interactions with the negative rule. We know there's a 4 somewhere in here. Because 4 is not there, it's not there. So there again, 1 and 4 must be on opposite cells of a diagonal. 9 can't be here. Where is 3? 3 is not in here. 3 could be anywhere there, just not next to the 2 and not next to the 7. I'm not seeing it. Is it about this digit? This digit won't appear here. It won't appear here, so it must be somewhere in here. That doesn't seem to resolve. What about this column? Those 2 digits are not here. Can they be both in here? If there are 3 and 8, that's certainly a possibility. We could have 3, 2, 8, and 7. Oh, I'm just noticing. Here we have the digits from 5 to 9. So because of this here is restricted to 6, 7, 8. And that gives me something. Now on this column, I could have seen this earlier. 1 and 2 can only be in this cell and in this cell. So that's the 1-2 pair. And this now is the missing digits from this quadruple, 3, 6, 7, 8. And none of them can be ruled out by this one here. Now I'm seeing that 9 in this box can only be here or there. And it makes a big difference because if 9 is here, then this can no longer be a 1. And now this is a 1. But if 9 is here, then this is a 1. And something I'm seeing is that in both cases, well, I just mentioned that this could be a 1, but if this is not a if this is not a 1, then this becomes a 9, in which case this can't be a 1. So in both instances, I can remove 1 from this cell. Which still leaves a lot of possibilities. Oh, I've been missing this. There's a 5 somewhere here, so this will never be a 5. That's a 5. And of course, that's just one more digit, but that's still one digit. So, is there anything to say about the position of 1 in those 3 cells? Oh, this puzzle is tricky, definitely. So what am I missing here? I'm saying no. I was saying something that's wrong, so I won't mention it. Those 2 digits must appear somewhere in here. That's probably the question, whether those 1 and 4 can be the same as this, which amounts to saying, can those be 2 and 3 like those? In which case we have a 2 here and a 3 there, a 1 there, 9 there. That seems to work very well, I'm afraid. But is there anything wrong if I assume that this is a 1-4 pair? Meaning 1, 4, 9, and 6. In which case I get 6, 1 here. So that's the 2. Is there anything wrong? Let's see. In this case, this can only be a 7. Here we're left with a 3 and an 8. That's a 1. So let's just explore this option. So here that's a 6, that's a 1. So this can't be a 9 because of the negative rule. So that's a 9. Up to this point, it works perfectly. That's 3 or 8. And I'm not seeing any issue with this theory. Perhaps there is an issue in this area, but I'm really not seeing it. So that's definitely not what's intended. Oh, this 5 is correct. So is there something wrong if I assume that I have 2 and 3 in here? What have I done? What did I do? This could never be... No, this could be a 1, but this could never be a 1. That's it. Because this is not a 9. So is there anything wrong? If I put a 2 and a 3 here, 7, 8, then that's a 6, that's the 1, that's the 9, and that's the 3. Oh, and that's the 2. And this is, no, sorry. And that's a 4. Actually, there's a much nicer way of saying this. 4 is here or there. And 9, yes, that's it. 9, oh, sorry about that. 9 is here or there. No. Is that what I'm supposed to see? Yes, and that's it. And if I try to put the 2, 3 pair here, then 4 and 9 will both be pushed into this cell, which is what Simon Anthony calls a Schrödinger cell, which is not allowed. So that's the reason the 2, 3 pair here is impossible. It's because they would push 4 and 9 both into this cell. Beautiful. So that's 1 and 4 with the 9 and the 6. And now this is none of them. So that's the 2. This can't be a 6. This can't be an 8 because of the negative rule. That's not 7. That's not 6. And here this is 3 or 8. This 6 now resolves the 1, 6 pair here. This can't be a 9 anymore. So that's a 5. That's the 9. That's the 2 and that's the 9, considering this quad. And then this is not a 2. That's the 1. That's not 4. And then this one prevents this from being a 9. So 9 is here. This is 3 or 8. And this is all good. With this one now, this 9, sorry, 9 is pushed into one of those two positions, and 1 will be on the opposite cell on its diagonal. So we have here 1 or 2, here 2 or 9, 8 or 9, 8 or 1. And I think I removed the corner pencil marks. Oops, to just unclutter my pencil markings. All right, so what do we have next? This is really good progress. We know that 2 is not next to the 3, so this is 105, and this is from 135. We must have a full, must have a 6 somewhere in here, and that's really not spectacular. This can't be a 2, so this is from 5, 6, 7. So is there anything direct that I can deduce? Oh yes, this one foresays that this is now a 2, 3 pair, and this is from 7 and 8. So here we need 5, 6, 8, and 9. This is not 9 by Sudoku. This is not 8 because of this 2. And those are not so restricted. Here we need 4, 6, 7, and 9. And I'm not seeing any restriction on them, except for this one. If this is a 3, then this can't be a 7 by the negative rule, and if this is 7, then this can't be a 7 for the same reason. No, just by Sudoku, sorry. So now we've removed 7 from all of these, so there must be a 7 in here. So this is 8, so that's 2 and that's 3. So that's not 7 either. Oops. All right, so the battery is on. This 2 prevents this from being 8. We must have a 1 somewhere in here. don't think I can find where it is right now. So those are from 4, 5, 6, 7. There's still some work to do. Something interesting here is that 4 and 6 are not next to each other. But that's not so powerful. I've been missing this. 7 can't be next to the 3. There's no 8 here. 8 is there. And it disambiguates all of this. So the 2 is here. 7 is not next to the 3. So here we have a 5-7 pair, and this time I don't think this can be disambiguated, neither can this. All right, so now 3, 7, 8, 9, we just know that this 3 and 7 are not next to each other, so this is 8 or 9, and there will be a 3 or 7 here with an 8 or 9. So what about 2? 2 is not here, and it's not here by Sudoku, so 2 must be here or here. And this cell between the 2 can't be a 3 or an 8 by the negative rule again, so it can only be 5 or 7. No, sorry, it can't be a 5. So it can only be a 7. So 3, 5, 2, and 8 have been ruled out. 7, so that's not a 7, and this is a 7. We know that these two digits are not a 4-6 pair, so one of them must be here. This is 4 or 6, so this can't be a 6, because 6 will rule both options out of this. No 7 here. I still need a 2 somewhere. And I still need a 3, but 3 is not on either side of the 2. So 3 must be here, on this row. And this is not a 3 anymore, so that's the 3. It can't be next to the 2, so 2 is here. This is 5 or 8. 5 or 8, so this is 9. There must be an 8 here, but there's already 8 there. So this is 3 or 7, but there's a 7 here, so that's 3. That's 7. And no 7 there. This is no more a 9. On this row, what about 8? I'm not seeing anything. Oh, but there's a 5-8 pair here, so this can't be a 5. That's the 6. So there's a 6 here. No 6 here. Down there we need the 1 and the 5. But 5 can't be here because it's up there. So that's 1, that's 5. I need a 5 somewhere here. That's not so nice. 5, 1, 4, 6, 9. Well, not sure what to do with this. Here I need a 2 and a 4. So is this useful? 2 would make this 9. 2 here would make... No. Let's have a look at this. We need 1, 5, 6, and 7. 7 is not in here. And I'm not sure I'm seeing any other restriction. Bobbins. So there's a 5 in here, so that's not 5. The options here are 6, 7. Oh, there's been a 5 here for years. So that's an 8 and that's a 5. So this 8 makes this a 4. That's a 2. So that's 1, 8, 9, and 2. No 1 in here. This 4 prevents this from being both a 1 and a 6. So that's 5, 6, 7, 1. 4, 1 here, 6, 9. 9 and 4. So I have been missing really direct deduction. So this one here makes this a 5. That's the 1. 1 is not next to the 4. So 6, 7, and 8. So this is 8 by Sudoku. This 9 makes this a 5. That's 8. That's 9. I still need a 3 here. Here I need a 7. It's not next to the 3. That's the 4. 6, 5. This 6 here disambiguates that. 3, 6. I was saying 3, I think. 4 and 3. That's 7. That's 5. And that's 6 and that's 7. Yes. Oh, toutes nos félicitations. So thanks a lot, Adam. That was a much more difficult puzzle, but very enjoyable. And I really loved what was happening in this area, which was the solid breaking, I would say, which was really the tricky part, but it was very nice logic. It reminds me a lot of some fancy stuff we see in those weird classic Sudoku puzzles by Shai or Jovi. Those little deductions that are not really standard techniques, just, I would say, surgical examination. So thanks a lot for this very nice puzzle. That was a very nice gift. And see you soon on SudoKanard.